Start from nature, not from algebra. A spring vibrates, a wave travels, light and quantum amplitudes oscillate. Repetition means there is a phase. One clean cycle can be tracked by a rotating arrow. The arrow is not just a height. It tells where the system is inside the cycle. That arrow stores two physical facts. Its length is the amplitude, how much. Its angle is the phase, where in the cycle. If we look at the rotating arrow from one side, we see a natural back and forth motion. A full rotation becomes one oscillation. The horizontal shadow of the rotating arrow is cosine. It rises, falls, changes sign, and repeats. The vertical shadow is sine. Sine is the same cycle, shifted by a quarter turn. A single real number keeps only one shadow. Two different phases can cast the same real shadow, so the real line has forgotten information. To keep the lost information, we add a perpendicular direction. That new direction stores the part of the cycle that the real line cannot see. A complex number keeps both pieces at once. In z equals a plus bi, a is the real shadow, and bi is the perpendicular phase component. The symbol I means one unit in that perpendicular direction. It is not fake, it is the unit step out of the real line. Multiplying by I turns the whole state by 90 degrees. Starting from 1 times I lands on the vertical direction. Do the same turn twice. 2 quarter turns make a half turn, so I squared lands at -1. So the square root of -1 is not found by walking along the real line. It is found by rotating out of the line. Euler's formula gives a name to the rotating arrow. E to the it is cosine t plus I sine t. A wave is the same idea unfolded in space. The curve we draw is one visible projection of a rotating phase. When two waves have the same phase, their complex arrows point the same way. The result is larger, and the visible wave reinforces. When two waves have opposite phase, their complex arrows point against each other. The result can be 0, and the visible wave cancels. That cancellation is nature showing us that phase matters. The imaginary direction may be hidden from direct view, but its consequences are measurable. Often nature measures squared magnitude, brightness, sound intensity, or quantum probability. For z equals a plus bi, that is a squared plus b squared. Sound, light, and quantum states all need the same mathematical memory: amplitude plus phase. So imaginary does not mean unreal. It means one real line was too small to store a full oscillating state. The natural meaning is this: a complex number is phase memory for oscillating systems.